Today I start on important topics related to major theory, especially in LC space. Okay, we start one important theorem. This one is familiar theorem. Okay, this one is familiar theorem. Riesz representation theorem. Okay, we also state and prove this important theorem. Today we start it. Now we'll write the statement of this theorem. Okay, so here let x this algebra script a mu be a sigma finite measure space, be a sigma finite measure space, be a sigma finite measure space, and let p belongs to close to 1 plus infinity. Okay, with conjugate exponent, with conjugate, okay, exponent q, with conjugate exponent q, then for every bounded, bounded linear functional, t, here LP x is this goes the script a mu to k, there exists a unique element G. There exists an unique element G belongs to LQX, this algebra mu, such that here TF equal to integration FG d mu with respect to x for all f belongs to LPX, this algebra mu. Okay, and norm t equal to norm c. Okay, so what happened? We talk about now. Let x the script a mu be a sigma finite measure space, and let p belongs to 1 plus infinity with conjugate exponent q. Then for every bounded linear functional TLPX script a mu to k, there exists an unique element C belongs to LQX script a mu such that TF equal to integration of FG d mu, okay, with respect to x for all f belongs to LPX script a mu and norm t equal to norm c. Okay, so we have to prove that that Riesz representation theorem. So we also considered we have proved the theorem in following cases. Okay, that means we prove theorem, prove here, we write it now. We prove the theorem for the following two cases, for the following two cases. Okay, first one mu b finite, second one mu b sigma finite. Okay, then we're going to prove of that. That means first we assume that mu be finite. Okay, we erase that portion and going to further discussion of that. Okay, so we now going to first we assume that we write it now. First we assume that what mu be finite. Okay, mu be finite, that is 0 less than equal to mu is less than plus infinity. Okay, then what happened? Now note that here this psi e. Okay, norm p to the power p equal to what? Equal to integration of x psi e. Okay, mod of this p d mu whole to the power 1 by p whole to the power p equal to what? Equal to integration of x psi e whole to the power p d mu equal to what? Integration of x psi e, okay, d mu equal to what? Equal to mu e equal to this less than equal to plus infinity. Okay, for all e belongs to this algebra A. Then what we get, we also marked as this one is 1, and we get thus this psi e. Okay, psi e belongs to lpx, this one equal to lpx descriptive mu. Okay, then psi e equal to this one. Now we're going to further discussion of that. Okay, so we write it now here. That means let t lpx to k, okay, be a bounded linear functional, be a bounded linear functional, and define comma here descriptive to k by, okay, gamma e equal to t of this psi e. Okay, for all e belongs to this algebra. Then what happened? Then we also, that means write about that. We now show that okay, first one real of gamma and imaginary of gamma. Okay, are sigma finite measure, are sorry finite sigma sign measure. Okay, finite sign measure, and next to real of gamma and imaginary of gamma. are absolutely continuous with respect to mu, absolutely absolutely continuous with respect to what happened mu. Okay, then we erase that portion and going to further discussion of that. Okay, first one, gamma b sign measure. Okay, gamma b sign measure. So what we done, note that here gamma phi equal to what, equal to t of psi phi, equal to what, equal to t of 0, equal to what, 0. This implies that real of gamma equal to 0 and imaginary of gamma equal to 0. Okay, now let En, okay, let En be a sequence of disjoint, be a sequence of disjoint measurable sets in script A. Okay, and let E equal to union of n equal to 1 to infinity En. Okay, then we claim that here gamma E equal to summation n equal to 1 to infinity gamma En. Okay, now we're going to further discussion of that. Since mu be countably additive, then mu E equal to mu of union of n equal to 1 to infinity En equal to summation of n equal to 1 to infinity mu of En less than plus infinity. Okay, then what happened? Then limit n tending to infinity k equal to 1 to n mu of ek equal to mu of e. Okay, then what happened? It follows that limit n tending to infinity k equal to n plus 1 to infinity, here mu of ek equal to limit n tending to infinity mu of union of k equal to n plus 1 to infinity ek equal to 0. Okay, then what happened? Then we erase that portion and going to discussion about that. Okay. Now from one we get yeah psi of union of k equal to 1 to n ek different sign of e. Here p to the power p equal to psi of union of k equal to n plus 1 to infinity ek, okay, whole to the power p, norm with the norm p whole to the power p equal to mu of union of k equal to n plus 1 to infinity ek tends to 0 as n tends to infinity. Okay, then what happened? Thus here summation k equal to 1 to n, okay, psi of ek equal to psi of union of k equal to 1 to n ek, okay, converts to psi in lpx, okay, as intending to infinity. This implies that here k equal to 1 to n infinity psi of ek, okay, equal to psi of e. This implies that t of k equal to 1 to infinity psi of ek equal to p of psi of e. Okay, this implies gamma e equal to t of psi e equal to t of k equal to 1 to the infinity psi ek equal to summation of k equal to 1 to infinity t of psi ek, okay, equal to k equal to 1 to infinity here gamma of ek, okay, then gamma of e equal to this one. So this implies that gamma is countably additive, countably additive, okay. Then what happened? Then obviously we write about it, hence gamma is k valued sign measure, okay, k valued sign measure on this x, this algebra a, okay, and and hence hence real of gamma and imaginary of gamma are also sign measure. Okay, are also sign measure. Okay, now we also erase that portion and going to further discussion of that. Okay, so what we see, gamma is countably additive and gamma is k-valued sign measure on x50, and real gamma and imaginary gamma are also sign measure. Okay, so now we're going to discussion of another portion. Here we mark as 2 gamma is absolutely continuous with respect to mean. Okay, then we write here for this. Okay, for this let E belongs to this script A. Okay, with mu E equal to 0. Hence, what happened? Hence psi E equal to 0 mu almost everywhere on X. Okay, and thus what happened? Thus gamma E equal to here T of psi E equal to T of 0 equal to 0. Okay, it means that what, gamma is absolutely continuous with respect to mu. Okay, hence what happened? Hence real of gamma is absolutely continuous with respect to mu, and imaginary of gamma is absolutely continuous with respect to mu. Okay, so this one is done. Now we going to further discussion of that. Okay, that means since mu is finite measure, since mu be finite measure, okay, and gamma is sign measure and gamma be sign measure. Okay, then what happened with gamma absolutely continuous with respect to mu, then by radon Nicodemus theorem we get, okay, we get there exists an integral function, okay, g on x such that what, gamma e equal to integration of g d mu. Okay, with respect to e for all e belongs to this script A. Thus what happened, we now erase that portion and going to further discussion of that. Okay, here thus t of this psi e equal to gamma e equal to integration of x psi e g d mu. Okay, for all e belongs to this script A. Okay, we marked as 2 let phi be a simple function on x, simple functions on x, then phi belongs to LPX, then phi belongs to LPX. Okay, then then for x equal to union of I equal to 1 to n, I equal to 1 to n ai. Okay, with ai intersection aj equal to pi for I not equal to j. That means ai's are disjoint, and we have what? We have phi equal to, okay, phi equal to summation of I equal to 1 to n. Here alpha I, this psi ai. Okay, for some alpha I in k by linearity of t, by linearity of t phi equal to t of summation I equal to 1 to n alpha I psi ai. Okay, equal to I equal to 1 to n alpha I t of psi ai equal to what? Equal to I equal to 1 to n alpha I equal to 1 to n alpha I integration of x, okay, psi ai g d mu. Okay, equal to what? Integration of x, here alpha 1 psi a1 alpha 2 psi a2 dot 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 alpha n psi an. Okay, g d mu. Then what happened? Then this one equal to integration of x phi g d mu. Okay, then what happened? Then obviously we write it now. Okay, then we write it now. This one, note that t lpx to r be a bounded linear functional. Okay, bounded linear functional. Then what happened? We erase our portion. Okay, then integration of x phi g, okay, d mu, this mod equal to d phi, okay, less than equal to norm of t, norm of phi p. Okay, hence what happened? Hence g belongs to lqx, and we now show that what happened. We now show that tf belongs to integration of x if g d mu. Okay, for all f belongs to lpx. Okay, Then let is equal to x this 50 mu denote the set of all simple functions on x, of all simple functions on x. Okay, then is this mu be dense in LPX, be dense in LPX. Let A belongs to LPX. Let A belongs to LPX. Okay. Hence there exists a sequence. Hence there exists a sequence. Hence there exists a sequence phi n in S x is 50 mu. Okay. Such that what? Such that limit n tending to infinity norm of phi n difference a p, okay, equal to 0, that is phi n converges to a in LP by continuity of t, we get tf equal to t of limit n tending to infinity phi n equal to limit n tending to infinity t of phi n equal to limit n tending to infinity integration of phi n g d mu. Okay, then what happened? We erase that portion and going to further discussion of that. Okay, by Holder's inequality, by Holder's inequality, integration of x here phi n g d mu difference integration of x f g d mu equal to integration of x here phi n difference f g d mu less than equal to integration of x phi n difference f g d mu less than equal to norm of phi n difference f norm of gq converges to 0 as n tending to infinity. Okay, then what happened? Then we write it now, therefore, okay, therefore tf equal to integration of x f g d mu for all a belongs to LPX. Okay, now we write it now. Let g dash belongs to LQX. Okay, such that such that TF equal to integration of x f c dash d mu. Okay, for all a belongs to LPX. Then we erase our portion and going to further discussion of that. Okay, we write it here. Then integration of x f of c difference c dash d mu. Okay, equal to integration of f c d mu difference integration of f c dash d mu. Okay, then this one equal to tf difference tf equal to 0 for all f belongs to lpx. It follows that, okay, it follows that g equal to g dash mu almost everywhere on x. Okay, then what happened, we also prove this uniqueness of g, and we also, that means get this one tf equal to integration of x f g d mu are for all a belongs to lpx. Okay, we get a g, and c belongs to obviously lqx. Okay, so we also prove that important theorem. Okay, Riesz representation theorem in measure theory. If you get this type of video, please subscribe my channel, and if you give like, please raise like option and click like option, and obviously if you have any question, comment, suggestions, please write it in comment box. So today I stop here.